So this is the 9.9 practice. I'll go through each example in some more detail. That way, in case something's not clear, you can kind of work through this and feel free to forward through and find the questions that you're struggling with. The answer key, of course, is still posted on Canvas under the Unit 9 notes packet, so you can scroll through to find this as well. All right, so we are going to keep applying some of those theorems that we saw yesterday from 9.8. Those are called like angle relationships in circles. And so I gave them kind of just some names to help with like the mnemonic. It's like a mnemonic device. You don't have to memorize the names or the number, like the theorem number, but you do have to know how to apply it. So when I see a picture that looks like this, that 120-degree angle is corresponding to the arc that it opens up to. So this was theorem, I don't remember the number honestly, because I just remember it with the little mnemonic device, but it was the first one. So it's after inscribed angles. So it would be chord and tangent is what I was calling that yesterday, because there's a chord and a tangent and it creates that angle and the arc that it's kind of like it's the idea is it's an inscribed angle sort of with an intercepted arc. But remember, whenever the point of the two lines forms on the circle, which is what's happening right here, it always is going to be half of the arc. The angle will always be equal to half of the entire arc. Well, I know what the angle is here, and I'm trying to find the different arcs. So I would just use this idea that I have to double this number. So 120, if I double that, it would be 240 for this entire arc here. Let me do it in another color so you can see this from A all the way here to B. So ACB, which is what we are asked to find here, that would be 240 degrees. So the measure of arc ACB is 240 degrees. The nice thing with these is there's really not much work. You just have to remember what each thing says. To find the other leftover, now you can do a couple of different things. You could just do 360 minus 240. That would be the easiest to help me find the measure of arc AB. I would just have 360 divided or minus 240 is 120. So that would be the arc measure of A to B. Okay, but if I also wanted to know the angle down right next to it, I could also see that this is going to be a linear pair. So 120 degrees plus 60 degrees would be 180. And that also makes sense because 60 doubled is this 120 here. All right, that's pretty much it. These do tend to go pretty quick once you really know what those rules are. So not mixing them up. Okay, so here's another one. This one starts with the idea of inscribed angles. And then let's see if it uses anything else. So this is that first theorem. Again, I don't remember the number, but we did it kind of in it, just very similar to chord and tangent, same idea. But when the point is on the circle, we want to think of it as the angle is half of the arc that it's opening up to, or the intercepted arc. So in this case, it also tells me here that we have some parallel lines. Before we look at the parallel lines though, let's just do what we know about inscribed angles first of all. And this 27-degree angle will make it so that the arc measure that's across from it is 54 degrees, right? So that's going to be 54. But that wasn't really asked in my problem, so it's just kind of extra information right now. I do know then that this is also going to be 27 degrees because both of these angles are opening up to the exact same arc, this AC. Okay, so then we look at the piece of information that was given about parallel lines. So this is a recap back from Unit 3, first semester. When we look at parallel lines, we have some alternate interior angles, corresponding angles, all those different types of angles we mentioned. On this diagram specifically, if I mention the parallel lines, that's this one, BC with DA. And remember, with parallel lines, you can only have one transversal at a time. So we could just be looking at, let's say, this transversal, BA as a transversal that's connecting my two parallel lines, kind of ignore the other line that's there. And so the alternate interior angles here, this is 27, this angle right here should be 27 degrees as well. So 27 for this angle. Also, you might say, well, what about this one? Same thing, actually, because that one was opening up to this angle. These are both 27 because of alternate interior angles again. But here's another way you could think about this is this angle here, or this arc measure DB is opening up to this 27-degree angle and this 27-degree angle we just found here. So this is also 54 degrees for the arc measure. Again, it wasn't asked. It didn't say what is the arc measure of AC or DB, but if it was, we would know those. We are asked to find the measure of angle BEC. And so that's this angle here. If we already know these two are 27 and 27, you can just subtract both 27s from 180 because we have a triangle, and that's how we get 126. Okay, so we use the idea of inscribed angles and also parallel lines, alternate interior angles. I'll write that here. And then our final answer would be measure of angle BEC equals 126 degrees. All right, so let's go to the back page and we'll try out a few more kind of using the different theorems. So far we just kind of worked with two of out of the 4 theorems that we worked with. So let's try the other ones. Okay, so we have number 3. It says to find the arc measure for DE, but again, it is another chord and tangent one, which means I have to take half of the angle, half of the arc measure to get what the angle is. This time I know the angle, so I have to double this angle to get this arc measure, DFE. So this would be 220 degrees. And then to figure out the other arc, you can again just subtract from 360, and that would be 140 degrees. So this is 140 degrees. Also, you could instead find the other angle here, that those are going to be supplementary because those are a linear pair. So once I know that's 70, I can also just double it this way. So I didn't have to figure out this 220 because the final answer is just what is the measure of arc DE? It is 140 degrees. Okay, so not too bad, hopefully. So far, we've used only those first 2 theorems that dealt with what happens when it's on the circle. Now we go on to the next one where it's in the circle. The 2 lines are meeting inside the circle. So this one was the one I called crossing chords because there's 2 chords that cross one another, kind of meet at some point. Remember, it does not have to be 2 diameters. They're not meeting at the center necessarily, so don't assume that these are semicircles or any of that. We just don't know what they are until we look at some of the arc measures. So the theorem here was the angle measure is equal to 1/2 of the 2 angles across from that angle that we're looking for. So the 112 plus the 140. Now, if you don't know both of those angles, arc measures, and you're looking for an angle, you really can't proceed with figuring this out. You can only have one unknown. And so my unknown is the angle right now. I have to know both arc measures. Or if I knew the angle, I would need to know one of the arc measures and find the other. So there's always got to be only one unknown at a time. So to finish this one up, this would be 252, and I'm cutting that in half. So it comes out to 126. So when you write your answer, since the degree symbol is already written there, you technically don't put the degrees. I'm not going to be taking off for that, but it is best to leave your answer just like this. It's different when I write down the measure of angle, whatever, or the measure of arc, whatever, and then I put a degree symbol that's different than just saying X is this and the degrees is already there. Okay, and then finally, this last one has quite a bit of work to it and kind of does involve some trig, which I have mentioned, we're not going to see a lot of that trig come up because it's more so stuff for the final exam eventually, or next year for Algebra 2 with trig. But for honors geometry stuff, let's see at least how to apply the theorems, right? So this does use the idea of the exterior angles theorem, but it's a little bit tricky because not very much has been given here. So let's see what we can figure out. Let me just kind of look at the diagram here and notice that this right here is 2, but if you realize that DE is the radius, which is 4, that means this is also 4 from E to this point on the circle, because that's another radius. So if I was to just kind of pick this triangle apart, this right triangle that's on top or the bottom one, let's just work with one triangle at a time and see what information we know, because we are being asked to find the value of A, this whole arc measure here, in order to do that, I'm probably going to need to know other parts of this triangle, or not even just a triangle, but other parts of this diagram. Okay, so let's start with just this. We have a right angle here. That's this one here. I'm going to label the letters here as well. C, D, E. Okay, we know that this side here is 4 because that's a radius, and we know this entire hypotenuse is not 2, it's 6 because it's 2 plus 4, right? So the whole thing, if you wanted to kind of see what part that is, or write the whole thing as 6. So we know 2 out of 3 sides of this triangle. We can then use sine or cosine or tangent to help us find this angle, because once we know this angle, it's going to be doubled. Both of these angles are these triangles are the same. So if I can figure out what this angle is right here for this angle C here, DCE, I can double it, and that'll be my whole exterior angle. And then I'll use my theorem to help me find A, or the measure of arc A right here. Okay, so let's start with, in this case, if I know that I'm looking for this angle, I would do opposite over hypotenuse to help me find the measure. Or actually, you know what? I'm not going to find this angle. Let me find this angle instead. And the reason for that is this angle is a central angle then. If I know what the central angle is, then I know what the arc measure is here for DA. And then I can just subtract from 360. That's going to probably be easier instead of using it to find the exterior angle instead, but you could technically find either one. So if that's the case, this is my adjacent and my hypotenuse. So I'm going to do cosine inverse of 4 over 6. Okay, and then I use my calculator, and just for just so I don't have to type it all out, it came out to about 48.189. Remember, you'd have to be in degree mode if you have a graphing calculator. At this point, this is only this part of the angle. I want all of DEA here because it's the central angle, and that will help me then figure out the arc measure that it's opening up to. So I double it. And that would tell me that the measure of angle DEA is approximately, because we are rounding here, 96.37 degrees. Okay, so if we know what measure of angle DEA is this, we also know now that arc DA is also 96.37 degrees because that's a central angle opening up to this arc. And then finally, to figure out arc A here, we just have to do 360 minus this leftover arc, or the arc that we just found. So 360 minus 96.37 tells me that the measure of arc, well, we don't have to write measure again because we already know it's A. So this would just be A equals 263.63. Okay, so that right there is the answer. Again, I don't have to put degrees just because it was already included with the diagram. So that's the final answer for A. I'm going to move that up so you can see on the diagram right now that this is what we just found, A. And altogether, 263.63 minus, or adding to that 96.37 should equal 360 degrees. I know we round it, so it's a little different, but that's all that would be. All right, so hopefully that helped a little bit. If you have additional questions, please feel free to send me a remind or email, and I will try my best to kind of keep up with any questions that you might have. Check the answer keys that are posted as well for all the homeworks, as well as the notes keys, the practice keys, all of that as well. All right, have a great day.